Hi, making a DraftScience video. Alright, so I did start a response video to Hofladay. I got about 15 minutes into his video, and there was the point, well, something like 10 minutes, point where he said something where he plays my clip saying, "This is a waste of my time." And then he said, "Yeah, you are doing it, aren't you? Yet you're doing it." And that's where I said, "Yeah. And why am I doing that?" There was no argument about physics. It was just personal attacks. His video is a piece of shit, just a waste of time, as the first video was. It's like, well, why am I wasting the time? And there is no good reason. I mean, I did it as like a benefit of the doubt. I mean, there was one point where I thought Hofladay might have something called some kind of intelligence, like more than a 60 IQ. And I was wrong. It's just that simple. He has nothing of value to say. If he hasn't read it somewhere and somebody didn't tell him what to say, he can't think. He has no capacity to do logic. So there's just it is a waste of time. So I concede the point. So I really will just stop looking and stop paying any attention to a troll. And that's all he's become, is a stupid, petty troll. An ignorant, petty troll. Yeah. Of just no value. There's just not a single bit, a kernel, a use. There's just nothing. Nothing. Just a waste of time. Yeah, so anyway, I'm done wasting time. So anyway, I have drawn the pictures for magnetism. So these all sell in the future for, trillions of dollars. Just no doubt. But this is the clincher. The fact that this theory just completely explains magnetism. I mean, it just makes it obvious. You're just like, oh, it's so fucking obvious. And it connects so well to gravity. And it's just like, oh, shit. So it's game over. So I just thought I'd make this video. Because, I have to write this. I have to explain these two images. And, because it's all there. It's just that it's a tiny bit complicated. But it's not very complicated. So let's look at this first one. Hopefully you can see that. But if you go to the web page, you can see the images. So the idea, these are two magnets of opposite polarity. That's the red and the dark, the blue. So these are red, blue, and green. So understand the color variations. So these two magnets would attract. Okay, and they attract with a pressure much higher than gravity. Obviously. Nothing, magnets are special that way. Alright, and so what's happening is these are polarized. So that means they're filtering. So they're filters, like a visual filter. They're only letting some of something. They're interacting with some of it. They're not interacting with the rest. That kind of a thing. So the idea here is this blue pole is sensitive, only to certain kinds of this polarization. So let's say the gravitons have a polarization that goes all the way around in a circle. We'll just do 2 dimensions for now, just because it's simpler. It's easier to draw, quite obviously. And so at any polarization, you could say, yes, okay, 1% of the polarization is this and 1% is this. You could just cut it to 99%, 100%. And so the idea is that there's 1% of the gravity is this coming in this way, and 1% is coming in this way all the time. So 2% of the gravity is polarized to the magnet's sensitivity. So the one pole is sensitive to the stuff going this way, the other pole is sensitive to the stuff going this way. So just understand that's the sensitivity. That means it will react as if it's gravity in a sense. So it will gain acceleration in a direction because of it. So it will work like gravity if it's that pole. So the idea is these are those two. So these are think of the blue as being this way, and the red is the horizontal. And so this pole of the magnet is twice as sensitive to this blue stuff and 0 sensitive to the red stuff. So that means it can't see the horizontal. It's like that gravity doesn't even exist. But this gravity exists twice as much, so to speak. So just understand that it's only a slight little inverse. You're just basically taking those two poles and just taking them out of the gravity equation and just saying that net balance is 0, because one is twice as strong and one is 0. So in net, it won't have any gravitational effect. So outside of being next to another magnet all by itself, this magnet is still doing this magnet thing, whereas it's actually more sensitive to one kind of gravity. But because it's zero sensitive to the other kind, it neutralizes out. You can understand that it has no the magnets aren't gravitationally sensitive, because it's basically as if this polarization and this polarization were just thrown out of the gravity altogether, and so it all is a net balance of the same exact pressure. So gravities don't react, so magnets don't react to gravity in any way different than every other piece of matter. Alright, just trying to emphasize that's the inverse here. Now the rest of the polarizations, that's this green part, that's the gravity. That's where the game gets tricky. That's where it really gets magnified in terms of the effect. Is what happens when it goes through this filter. The magnet's a filter, so recognize that it's okay, it's twice as strong to this gravity as this one goes through, and it's 0% to this. So that's a gravity neutral, and this is regular, the rest of the polarization of gravity. So the pressure of gravity is equal here. So the usual gravity is affecting it. It's being affected by gravity in the usual way, so there's nothing's messing up the gravity here. So we're just talking about the magnetism part. So anyway, so the filter takes all of the non-vertical polarization, all of the things that aren't vertical or horizontal, and it converts them, not all of them, but a certain percentage based on how much magnet you go through. So how much material you go through will dictate what your odds are of a graviton, one of these non-polarized, non-vertical, non-horizontal ones, what the odds are of that one being converted into a hard vertical. So if I said blue is vertical, so this is now vertically polarized. So a percentage of this gravity coming in from all directions is now being converted into blue gravity. So it's now been polarized. So it's that's what the filter does. And so it's shooting out now. So the stuff that comes in this side ends up getting polarized blue. The stuff that comes in this side gets polarized blue. So it's polarizing the gravity. So now anything that's sensitive to that polarization, like regular matter, isn't. So if all the gravity coming down on me now was polarized, I wouldn't feel it, because I'm not magnetic. I wouldn't notice the difference. It would seem like all the same gravity as usual gravity, because my body doesn't care what the polarization of the gravity is. Technically it does, but I mean the atoms care, but I'm just saying, for the sake of this argument, it wouldn't make much difference. So anyway, so all of this gravity has been turned into 2x gravity, if you can understand that. So if there was a blue thing here, it would be 2x gravity. But we're talking about things that push together. So everything it expels is this vertical gravity. Now the red pole, that's zero to it. I mean, you know, it doesn't see blue. Blue is 0 to the red pole. So that's like the gravity disappearing, because it goes right through it, doesn't see it, doesn't pay any attention, isn't affected by it. So the red pole isn't affected by horizontally polarized, and the blue pole isn't affected by horizontally and vertical. See, this is where, at least when I write it, I will I'll be able to make those corrections. So anyway, so you can just get the idea. Okay, so this one is exactly the inverse of this one in terms of its properties. So in the middle, you have essentially 0 gravity. If it was full, I mean, if this percentage of this gravity was if all of this was polarized in the 0 way to this would feel no gravity from one side and full gravity from the other side, and that's why it would move in. But obviously, it depends on how thick the material is. Depends on how thick the polarizing filter is. So if you have a big enough magnet, theoretically, you might be able to get to a point where you have actual 0 gravity, where you actually turn all of the gravity coming in into the polarization that has no meaning, and then you'll be feeling, in the presence of another magnet, the full force of 0 gravity, in the sense that there's no internal pressure at all felt by either body, and you have a perfect vacuum, essentially, of gravity. But that, like I said, that might take a magnet that's as big as the moon or something. So, but you can get the idea that that's why magnetism is so much stronger than gravity is because it's converting gravity from the reason why gravity is weak is because of this polarization issue, and because our matter can only absorb so much of it. So when it comes through us, most of the gravity goes right through us, because there's technically more gravity coming through us than matter in us. There's more bullets heading for the things than there are things inside of you, in a sense, because they happen over time. You have to understand the time equation means there's more mass in space than there is in us, in the sense that over time more of it will travel through us because our mass is stuck here, so to speak, technically or untechnically. You know, we seem to be in one place. Technically you're not, but I mean your atoms aren't. I mean the things that make you up are leaving, but the things that show up take their place, so it seems like we're not going anywhere, but we're always going somewhere, ironically. I mean, it's this thing. You know, stuff goes in, stuff goes out. I mean, it's this stuff actually changes. This stuff actually flies out, and the new stuff takes over, takes its place. I mean, that's what's really happened, but I don't know. Let's not get into that argument. All right, anyway, so so you have to sort of understand. So that's what draws these two things together, is that this gravity, all the non-polarized, vertical or horizontal, is converted into vertical. Vertical is invisible to this magnet, therefore all the external gravity now is pushing this one this way, and the inverse for this one, so the two of them end up pushed together because the gravity has now been turned into a zero force by the polarization. This gravity has been zeroed, and this gravity has been zeroed in terms of when it hits here, it's zero, and when it hits here, it's zero. It's still gravity out here, but it's zeroed in here. You should be able to understand. The inverse is even more obvious. So let's do the opposite now, where two poles are facing each other, because there you can understand the conversion even easier. So in this diagram, all right, it says 2 times the pressure plus all the pressure of all the unpolarized gravity quantons now polarized. So it's the inverse situation. So now the blue one, it's 2x sensitive to the blue gravity and 0 to the red. Well, it produces no red. It converts none of this usual gravity into red. So there's essentially all the red in this and all the red here, anything close to red, let's just say. None of that ever gets through because it's all converted into blue. And blue is what this thing is twice as sensitive to, okay? Because these are both blue. So it's twice as sensitive to these blues. This one's creating all blue now, and that's why the two magnets repel. Is because this one's creating the thing this is twice as sensitive to, plus, so you have 2x the force of gravity, you know, 2x the force of this amount of polarized gravity, plus all the gravity converted to blue. So now you're getting the full force of this gravity is being converted into something this is completely sensitive to. So where only 98% of this only 2 or 3% of this gravity would actually have an effect on something, it's now converted into something that's guaranteed to have an effect. And so it's much more than just twice as strong as gravity. It's as many times as strong as gravity as it polarizes this gravity. So again, depending on how thick the magnet is, will decide how likely this unpolarized gravity, that's not horizontal or not vertical, it's some other polarization, how much of that is converted into this depends on how much magnet it travels through. So the probability of it getting converted is higher depending on how much. If you just go through this little corner, well, your odds aren't as strong. But if you go all the way the length from this edge to this edge, that's the longest distance through the polarizing filter, that's where you're more likely to be gravitated. And ironically, this is where the strongest magnetic attraction is, right here. And strongest repulsion, obviously, is at those corners. Because that's where you're covering the most area in terms of the curve. So this density of area if you put an arc in here of all the gravity that can get to this corner, all the gravity that can get to that corner is more dense than any other location. If you go to any other location, you have a less dense field that would be able to get to it. So anything, I'm just saying, the longer you have as a distance, the more likely that's going to be your area of most. So whatever point you can find the longest line to still another blue piece. So it's not, just finish this line blue. So any point where you could make a longer line to get to another blue point, that is likely to be the place that has the highest gravity. Alright, so that's not too terrible an explanation. So what are the factors here that are important? Understanding that the non-polarized gravity gets polarized by the magnet, and it costs the magnet nothing. It doesn't consume any energy. So changing polarization doesn't require any work on the part of the magnet. But the reaction, when you get hit by something and it meaning something, the photon not being the same polarization, that's just like gravity. That's essentially an absorption of the graviton, and you will be accelerated. So that's where the acceleration comes from. That's why things move apart or move away, is because they're getting accelerated as if in an imbalanced gravitational field. And by imbalanced, I mean any gravitational field where two things aren't equally pulling or pulling on you. I mean, pushing or pulling. It's all, as this demonstrates, it's all push, in the sense that all you've done here is create, by filtering, by just taking out all the gravity that this thing's sensitive to. It's only 2 times sensitive, but you've made all of the gravity now into 2 times sensitive gravity. Alright, that's one way to say it. But that's what's creating the acceleration. So the acceleration that causes the movement is subtly different than the mechanism that causes the polarization. So I'm just saying the polarization is technically for free. The effect of this or this on the magnet will be dramatic. So even though it was a free conversion, it's going to have a dramatic effect on whether this other magnet will react. And again, it has to be something magnetic. So yes, it could be a piece of steel, but what really happens with anything anything this magnet can stick to is that it actually magnetizes the steel. So magnets don't stick to steel, they stick to magnetized steel. So they have to be able to magnetize it to stick to it. So that's kind of like why stainless steel doesn't work. It's because it can't magnetize it, so it can't stick to it. Even though it's got iron in it, this doesn't work because it can't magnetize the iron. Through the stainless process, it heats it and makes it magnetically neutral because of the high temperature, blah blah blah. So I don't know if I need to really drag this out. I mean, I have to do the writing to do what I just did. And so let me know if you understand that. But if you understand this, if you understand what's right here, then you really do understand this is the answer. Because this is so consistent with gravity. It ties the two things together just as tight as you could tie the two things together. It explains the dynamics of magnets, why they're stronger because they're thicker, because they are filters. I mean, it has it all there. It's all it diagrams the mechanism. It makes it perfectly visible. This is the model. Draw all the mathematics on it, but this is the model. Eureka. Yeah. So anyway, yeah. So stick that in your dog's ass holiday and smoke it. Fucker. Anyway. That's the last time I'll say his name. That's the last time. It's like some kind of 10 Commandments movie. Like Sponge, Judah, Ben-Hur's name or whatever. 2 different movies, right? Moses is, yeah. Sponge Moses' name from all the pillars. And all the valleys and anybody who speaks his name, I'll cut his head off and so forth. Fucking piece of shit. Anyway, till next time and such. So forth.